Bismillahirrahmanirrahim. Today I thought I'd do some examples of its sequences in series. Most of these, in fact, are just going to be sequences so that we can get some good understanding and practice with some of the basic concepts. I found these two questions. The instructions read, find the next three terms in each sequence. As you can see, they're given two sequences here, and they're infinite sequences because of those ellipses or ... that we see at the end. And they're just a listing of all the first few terms in this sequence, and we're supposed to figure out the pattern so that we can generate the next three terms. You kind of have to play around with the numbers here. Maybe here they're multiplying by 3, and if I multiply by 3 I should get 9. Okay, so that doesn't seem to be the case. Maybe they're just adding 2 every single time. It adds 3 plus 2, and if I add 2 you should get 5, but you're getting 6. Okay, that doesn't seem to be the case, but okay, you're adding 2, and here you added 3, and here you add 4, and you can see there's a pattern here. In the next term you're adding 5, and therefore that appears to be in fact the pattern. So using that, we can generate the next three terms. Okay, and then I have to add 6 to 15 to get the next term. 15 plus 6 would be 21, and then I have to add 7 to 21 to get the next term. 7 plus 21 is 28, and then I have to add 8 to 28 to get the next term, and 28 plus 8 is 36, and we are asked thankfully to only find the first the next three terms. So as you can see, we kind of had to play around with these numbers, and sometimes the pattern of the sequence is not readily apparent, and we kind of have to work a little harder than this sometimes, at least for me. Okay, let's see about the next one. -4 to -8. Okay, maybe I'm subtracting 4. Okay, if I subtract 4 over here, I should get -12. Okay, well, I'm not subtracting 4. That doesn't seem to be the case. Maybe I'm just multiplying it by 2. If I multiply -4 by 2, indeed I get -8. And then multiply by 2, I get -16. It looks like I'm just multiplying by 2 every time. So to get the next three terms, therefore, I multiply -68 by 2. That'll give me -128, and then I multiply that by 2. I get -256, and if I multiply this by 2 again, I'm going to get -512, and then the pattern would therefore continue. So here were two examples where we were provided, or we were given first few terms of a sequence, and we were to kind of figure out the pattern to generate the next few terms. And as you can imagine, the pattern is not always readily apparent. Here's a famous sequence. It's called the Fibonacci sequence. I've written out the first few terms here. See if you can figure out the pattern and perhaps generate the next few terms. You can pause the video if you like and try it out. So Fibonacci sequence is a famous sequence because apparently these numerical patterns are to be found in unexpected places in nature and in natural phenomena. So maybe you can Google Fibonacci sequence in nature, etc., and then you'll see some interesting videos. So Fibonacci sequence is as follows. So what you do is you add the two preceding terms to get the next term. So 1 plus 1, you get 2, and then you add these two terms to get the next term, and then you add these two terms to get the next one. So a sub n, basically, were to write a rule over here, it would be a sub n minus 1. You take the preceding term, and then you take the term that's preceding the preceding term, so to speak. So you take two terms that are consecutive terms, and you add them together to get the next term. So 5 plus 3 is 8, and 8 plus 5 is 13. Therefore, to get the next term, we add these two together, and the next term would be 13 plus 8, which is 21, and 21 plus 13, if you had to get the next term, 21 plus 13 is 31, and 34 like this, and the sequence would continue. So Fibonacci sequence is a very famous sequence. Okay, our next question is this one over here. We are to generate the first few terms over here. Let me just write the questions. To generate, let's say, the first 5 terms. In this time we'll call the series, in the series, because we've used sequences so far. So we're given this particular information. So we're told how to get a sub n in any particular generic n, and we're told what a sub 1 is. So here's a sub 1 is 9. We're told to get a sub 2, we are to take the a sub n minus 1, that's the term before it, and subtract 3 from it. So this rule, if you recall, is a recursive rule. So in a recursive rule, if you remember, you can generate a sub n based on the term that's preceding it. So we take the term preceding it in this case, which is 9, the term that's preceding a sub 2 is 9, and you subtract 3 from it, and you will get the subsequent term. So a sub n minus 3, so that's going to be 6. And in the same way, that's a sub 2, and then a sub 3 is going to be, you take the preceding term, which is a sub 2, it's going to be a sub 2 minus 3, and a sub 2 is 6 minus 3, and that's going to be 3. And a sub 4 is going to be a sub 3 minus 3, and that's going to be 3 minus 3 is going to be 0. And then a sub 5, let's go down over here, a sub 5 is going to be a sub 4 minus 3, and that's going to be negative 3. So if we were to write this series over here, because we're told that this is a series, the first term is 9, and then it is 9 plus 6 plus 3, and then plus 0, and then plus a negative 3 or minus 3, and then you can see the pattern here would continue, and like this. I'm sorry, actually more like this. So these would be the first 5 terms of this series. Now in this particular example again, we were given the recursive rule where you get a sub n based on the term that was preceding it. All right, I'd like to give you another example. Here's question number 4, and we're simply given this rule: a sub n is equal to negative 12 over n. If you appreciate, we're not given a sub 1 here because we can easily generate a sub 1 because in that case n would be 1. So we're going to write the first 5 terms of this series. A sub 1 therefore would be just negative 12 over 1, which is just negative 12. A sub 2 is going to be negative 12 over 2, and that's going to be negative 6. And a sub 3 is going to be negative 12 over 3, and that's negative 4. And a sub 4 is going to be negative 12 over 4, and that's negative 3. And a sub 5 is going to be negative 12 over 5, and that's negative 12 over 5 because you can't simplify that. And this is a series, so we can write this as a series. So first term is negative 12, and then plus negative 6 plus negative 4, or you can just write negative 4 minus 3, and then minus 12 over 5, and this would continue to infinity in this manner. So in this example, we were given the explicit rule, which is very powerful, and which gives us any term based on simply the n itself. So we don't have to know the preceding term or in the first term in this case to generate this series in this case. So this was an example of a recursive rule and that helped us generate the first few terms. And this was an example of an explicit rule that helped us generate the first few terms. Inshallah, we should do some more examples next time. Until then, as-salatu wa-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.